Is Vincent still here? I was going to say Vincent and Merilani can also get the gem paintings. Vincent, Merilani, you can also do your gem paintings. Thank you, everyone. Thank you, Tony, for the introduction. And today I'd like to talk about tanzanite. I spent 6.5 years underground after graduating from the University of Stellenbosch. Most of you know tanzanite is a relatively simple stone, blue-violet, violet-blue, but the true treasure of the tanzanite and all the years I spent there is truly in the geology. The science behind it is what truly makes it so rare. The geochemistry and the research that was invested into the gemstone and the mine at that stage, that was early 2000s. This is a video. Do you mind pressing play? There is sound to this as well, please. I was also fortunate back in 2016-17 under the third ownership of the mine after Tanzanite 1. 2004, Tanzanite 1 was officially became a public traded company on the London Stock Exchange. And then in 2009, ownership and management changed. And then I think later years, from 2012 onwards, the Tanzanian government got involved as a 50% owner of the mining license. I had the opportunity all these years later, when I then joined Gemfields, post that, to go back to the mines as a consultant to assist the Indian owners. And so, as in the early 2000s, you didn't have digital cameras and GoPros and etc. So it was fortunate to go back in the later years to be able to capture digitally video and photographs. And that's what I'm showing here today. This is now main shaft, the center shaft in that whole 7 kilometers of the 5 blocks. And I can talk for 5 minutes on this because this is how long it takes you to get to the bottom of this mine now. When I was there, it was only 100 and 200 meters down this main shaft incline in the skip. Today, it is almost a kilometer. Video again. What is so nice and what I would like to stress is kind of the rat hole look going down the shafts, the opportunity of using photography and videography in these operations. This was a large-scale colored gemstone mine. It was one of the first. And so today there are 8 or 9 around the world. I had a privilege of obviously being here in 6 years in the early 2000s, and then recently 2 years. And if you take the 6 years that I was with Gemfields, I had the opportunity of seeing this mine from from 2002 through 2017, which is almost a third of Tanzanite's 52-year history or life as in modern history. The best third as well. Briefly, a bit about the geology. It's part of the Mozambique belt, which extends from Mozambique through to Ethiopia and Somalia, the whole east coast of the African continent. It underwent high-grade temperature pressure metamorphism that was relating to the breakup of the supercontinent Gondwana. And then younger events, part of the actual breakup, actually resulted in the formation of tanzanite. And so 550 million years, what we call amphibolite green schist facies conditions, so lower temperatures and pressures, which created the tanzanite. A brief map of Tanzania, and then specifically the northeastern region. This is the Lelatama Mountains. Tanzanite is, all the world's tanzanite comes from this location on the northwestern edge. And all of this white rock is the younger sediments and volcanics. I will point out here from an interest perspective, if these volcanics, so Meru, Kilimanjaro, which is relating to the East African Rift that is splitting, if any of these mountain volcanic events happen nearer here, we would not have tanzanite today, nor tsavorite in that part of the world. There is another video, I'll skip that one. The true treasure, as I mentioned earlier, is its geological history, geochemical history. And back in 2000, my mentor, Bernard Oliver, who also worked with Tony for Richland, did a lot of his PhD in tanzanite. So a lot of geochemical work was done. And then with all my time, which I spent 6.5 years physically underground, looking at the grain sizes, the minerals that you see, seeing trends relating to production, no production. And so tying the geochemistry in with the actual physical observations, documentation, and descriptions, year on year, so 2002, 3, 4, the knowledge grew, the confidence grew, the success of the mine grew. And from a geological perspective, the summary, or what I want to stress here, is that at the high, garnet is a high temperature pressure mineral, forms at peak temperatures and pressures, and so green garnet was formed in that part of the world due to its geological and geochemical history. So green garnet formed first, and then there was a younger, later event through the upliftment of the marginal rock, part of the Gondwana breakup, around 550 million years ago, which created the tanzanite. And so on this diagram, basically a pressure-temperature graph, but indicating over here that the green garnet, high temperature pressure mineral, on the retrograde path, so the rocks were buried deep, high temperature pressure, and then upliftment, erosion on surface, temperatures and pressures dropped, and with that later fluid event, 550 million years ago, tanzanite formed or recrystallized from green garnet. And that's the intimate relationship between the two gemstones. And from an exploration perspective, of knowing this part of the world, like diamonds or search of diamonds, you're using garnets, ilmenites, etc., as dense minerals when doing exploration. What about using green garnet as an exploration mineral in search of tanzanite and other locations in East Africa? Just a description, the tanzanite itself is a skarn development, and so metasomatism and metamorphism. Essentially, it's a high temperature pressure environment with exchanging of minerals. So the aluminium and silica come from the hanging wall, footwall, and then the calcium magnesium is kind of part of the Boudin structure, and actually the rock that facilitated the tanzanite and other minerals to grow. And you can see kind of fractures, dark pockets here. It's literally voids in this brittle rock that allowed the fluid migration into low pressure sites to crystallize. You can see Bernard's photograph here. That's a green garnet. You can see the development of the blue-violet zoisite, not in the center, but actually on the edge, the outer edge, showing the recrystallization of the tsavorite into the zoisite, ultimately into tanzanite. Geochemically, just want to keep it, that's the geochemical formula, but simple with the vanadium, which I will talk about more important now, sits in the aluminium crystal site of the garnet, and simply put, ignoring the geochemistry, it's tsavorite with water and CO2, basically the hydrothermal fluids, in that younger 550 million year old event to create tanzanite, quartz, and calcite, which are the common minerals found in association with the tanzanite in those low pressure site pockets. Bernard did a lot of geochemical work. Only thing you need to take away from this is between the blue tanzanite that was seen, the green, orange, and yellow, ultimately is the main major element concentrations, which make up the majority, so calcium, aluminium, silica. And then the trace element work, which is kind of crucial for all the colors. And we'll get to heated, no heat, fancy zoisite, or yellow, green, gold, what is tanzanite, in a moment. But the main two elements here are titanium and vanadium for blue as well as green. And just kind of note the amounts. The vanadium is the higher parts per million, from 1,500 to 2,000 parts per million. And titanium part per million is lower. And then for the orange, Bernard even proposed that with the rare earth element, trace elements, that potentially you've got a new gemstone, with zoisite with high rare earth element amounts being kind of more orangey or golden color. Pictures tell 1,000 words, and this is on the B axis, the violet axis. Color zoned, low color, part per million vanadium, very low. Strong violet, part per million, 1,500 to 2,000. And then on the blue A axis, high on the boundary there, but once again, 2,000 parts per million. And because tanzanite is orthorhombic crystal system, the vanadium is the chromophore, meaning it gives the color. It's the violet color on the B axis, it's the blue color on the A axis. We all talk about heating. Can it be confirmed? And I know I've asked Chris Smith in the past. It's very difficult to actually tell whether it's earth or man heating tanzanite. It is easy, and with tanzanite being such a clean gemstone, typically you rely on your inclusion work and reaction of mineral inclusions to see heating effects. But for fine tanzanite typically it's very, it's a clean gemstone, and so you can't use inclusions. So typically if you've got calcium or more specimen-like rocks, you see an effect of heating, but it's not a telltale sign for tanzanite in general. My later years at the mine allowed me to actually attend the auctions. Before, in the early years, I was the geologist, I was underground, I had to make sure check the production, secure the production, extract it from the crystal faces. The later years, about 2 years consulting recently, allowed me to actually have a look at tanzanite from a gemological perspective. Before it was all geological. I had done my graduate gemology in Carlsbad by then, and so I could now critically look at and see volume at those auctions. And so, obviously at the auction level, there's no heat, so this is gems directly from the earth. A-axis, bluish green, as you can see here, violet on the B, and then the brown or red axis, the C-axis. This is where the heating plays the importance and why people are heating the tanzanite, which is by definition the blue-violet or violet-blue variety of zoisite. So it's the titanium 3+, which is green and gives the green. You've got your vanadium 4+, and with the exchange or valence exchange, titanium 4+ is colorless. And so what is happening, and I'll attempt to show you can play this video. The heating on the respective axes has an effect on each axis of the So just a rough crystal at the auction. So the blue A axis rotating 90 degrees onto the violet B axis, and then the other rotation onto the brown or red C axis. So this is my attempt to actually explain the effect of heating. Obviously, at auction, hasn't been gotten to the distributors or the buyers yet. So this is from the Earth. This is its blue A axis. You can see some green zoning, some green in the color. Typically, we describe that as greenish-blue preheating. The green is represented by the titanium 3+ trace element, And the body color, once again, is the blue vanadium chromophore. Rotated onto the B axis, typically, this is the violet axis. Now, lighting plays a part as well, and we'll get to that from a grading and a color identification perspective shortly. And once again, the body color being the vanadium, and then the brown C axis. So brown is again represented by the titanium oxide. This, after heating, as we know, becomes the second violet axis. So this is actually violet plus either a red, yellowy, green by the titanium 3+, mixing the violet with that color to give a browny look. So what is happening is, and you have to, like the geology, you have to think of the heating and the exchange, or the change happening on each axis. It has a part to play on each axis, almost thinking three-dimensionally what the color change is actually doing when heating is taking place. As I mentioned, lighting is a key factor in tanzanite, because now this is my daylight equivalent light at the auction, because each parcel, the buyers have an opportunity to look at the gems in both lighting. Daylight equivalent incandescent on the A axis. It's still the blue axis with the green, but here is, and also what I believe is color change on the one axis in blue, violet, zoisite, tanzanite. There is a color change under the different lighting. Daylight equivalent, you're getting a blue, and then under warm incandescent, you actually have your true violet axis. And this is a nice video to show the actual color change between the two lighting of one of the large crystals at one of those last auctions I attended. So this is the warm incandescent light under the daylight equivalent light. You can see the color change you saw initially. This is now on the A axis, the blue axis. So this you can see there's blue, and when we go back to the yellow light, you still see blue. So you can distinguish, you can clearly see the difference between here we go. You can still see that's the blue axis. So there's a bigger change on the B axis of those crystals. And that was also transmitted light. Here is reflected light. Gemologists also have asked me. And then also, we'll get to another point that I want to show, but here is the B axis, so the violet axis under incandescent, and here is that same axis, and if I go quickly, you see I haven't changed the orientation of the gems at all. It is the B axis, the violet axis, doing a color change under the different lighting. And what I want to question here, particularly for the guys who trade with tanzanite, this is the rest of the parcel, non-orientated, but all brown. That is the blue color, but you don't see any brown in that. Now, we always thought, even from a mining perspective, that's possibly heated by Earth. Blue-violet, there's no brown there. But remember, the tanzanite crystals are orthorhombic. It's a terminating crystal. And there is some thoughts that I do have on maybe that is not heated by Earth at all, but maybe that is the majority, the brick of the orthorhombic crystal terminating, and what is happening on the C-axis as the crystal terminates. Does it run out of brown looking down that brown axis? And that's both lighting, so you can see like a blue-violet on the same orientation of those stones. Just a couple of slides for I unfortunately should have done this in a different lighting. It doesn't show so much. That was now a crystal that supposedly was heated by the Earth. So you see the summary of heating of tanzanite is removal of the 3+ to a 4+, so it goes from green to colorless, so it intensifies the blue. This is the violet axis. It's still the effect of that change from a 3+ in that crystal. You're not really seeing any change on the B axis with the heating, but on the C axis, and this is what I meant, here's the brown. If you continue to slice away this crystal on this axis, as the crystal terminates, at what point, because you're not seeing brown all the way up to the termination of the crystal. So is it because the termination is taking place that you're just not seeing brown anymore, or is it Earth heating those crystals? But either way, the summary of the heat and the exchange reaction is the removal of the red, brown, yellow effect, which is the titanium 3+, to a colorless, to intensify, and yeah, and the lighting, it is supposed to be the violet main chromophore on that C-axis. And just before I completely end, tanzanite is heated experimentally. Tanzanite always changed from 280 degrees Celsius up to 720 degrees Celsius. Any higher, the water, the OH group in its crystal structure would dissipate. So from that perspective, tanzanite is one of the good things or nice things about it, ultimately, is that man can't create it. That's a powerful statement for the industry because from a gemological perspective, all orthorhombic crystals cannot be created by man, but geologically, it is the science behind and the geology from the retrograde path Earth made our beautiful tanzanite. And just in closing, when I started on that mine from a mining operational perspective, a marketing perspective, tanzanite was described as it's a single generation gemstone. That was early 2000s when I was involved. When I got more involved, the later years, I would say 2008, 2009, to the most recent consulting, the mine now is 3 times deeper than what it was when I was there. The price of tanzanite is probably 3 times less than what it was when I was there in the beginning. And so the single generation gemstone would be mined out in our lifetime. But if you look at it, it's not economical to mine any deeper or any further. So it's another single generation. Not that it's exhausted, but it's uneconomical. And then the only thing kind of politically or the reality or the situation of Tanzania right now, another single generation concept is the government involvement and the effect that it has on the industry that we're in. We've had a wonderful day, 2 days of talking about our industry, the involvement of the industry, members at respective paths and places in the industry, as well as at the ministry level. Now, you know, the third phase of a single generation is a negative government interference or position in the industry. Thank you very much.